As we said, the key idea is we're going to use this model of motion to make these predictions. And there are two goals, right? Goal number one is that we can do less work because of this. Because we have some idea of where the object is going to be, we can restrict our search. Goal number two is we should be able to actually improve our estimates because we're using both predictions based upon dynamics and our measurements. Now to do this, we're going to make certain assumptions. Okay? And the assumptions basically come down to the notion that this is some form of continuous motion. We're going to assume that objects don't disappear and reappear instantly somewhere else. For those of you child psychology, that's a whole Piaget thing. Kids don't come to that belief until, I don't know, it's like a year and a half or something like that. So like kids who are really little, if you take a toy truck and you've got a screen here and you put the toy truck behind the screen, and then you lift up the screen and the truck's not there anymore, they're not surprised. Things disappear in their universe all the time. Or it becomes a carrot. They're not surprised either. Then all of a sudden they get to a certain age when the truck comes back, if you pick it up and it's a carrot, they're like, whoa, all right? And that requires a certain change in a mental model. Okay, I don't know why I mentioned that. It's just really cool. It's true, by the way. Not that Piaget is all true, but that's true about children. Anyway, so we're going to make our assumption in our tracking that things don't just appear or disappear. We're also making an assumption that the camera doesn't move instantaneously. You know, because that would be the same thing, right? If I instantly went from here to here, right, big change, things will have violated my apparent continuous motion. So that's basically that there's this gradual change in pose between the camera and the scene and the object.